Hello everyone, we are from Wise Engineering College. We have done a project on chili leaf disease detection using AI and deep learning. It is presented by P. Jahnavi, P. Karuna, Jairazu, Naveen and Narendra. AI and deep learning helps to detect Michi leaf disease quickly and accurately. Using image processing and CNN models, diseases like leaf spot, leaf curl, yellowish can be classified. The file name is train main. Import numpy as np. We are importing the numpy library and assigning it as np. Numpy is used for handling arrays and performing mathematical operations. Import OS. Importing OS module which allows the interactions such as reading files and directories. From sklearn.utils, import shuffle. We are importing shuffle function from the scikit-learn. It is used to shuffle the data randomly. It is important for training machine learning models to prevent bias. Import matplotlib.pyplot as PLT. We are importing pyplot from matplotlib. It is a library for the data visualization. Import CV2. CV2 is for image processing tasks, which is like reading and resizing. Import TensorFlow as TF. TensorFlow is the deep learning framework which is used for building and training the neural networks. From TQDM, import TQDM. Importing TQDM, it provides iteration over the loop. We are defining the class labels. Class label means it is about different categories of the Michi leaf conditions. Whether it is healthy or leaf curl or leaf spot or white fly or yellowish. These are the categories of the Michi leaf conditions. Healthy means leaf without any disease. Leaf curl means a disease where the leaf curl occurs due to the virus. Leaf spot means a fungal infection on the leaf. Whitefly means a virus which causes damages in the leaf. Yellowish, where the leaf turns into yellow color due to the disease. Next, class names label. We are creating the dictionary which maps the class names to numerical labels. Next, it stores the number of classes such as in this there are categories like 5 categories which are healthy, leaf curl, leaf spot, white fly and yellowish. These are 5 classes. Like that it stores the number of classes, nothing but NB classes. Length of the class, it determines the length of class. Next, image is resized to 150 into 150 pixels which is used to maintain consistency. Specifying dataset paths, we have to specify train path and test path. R means rastering. Train path is nothing but it defines the path where training images are being stored, and test path means it is about testing images that are stored. Loading data function. Load data. Load data is responsible for reading and loading the images from the dataset. Dataset, it stores both training and testing dataset paths. Output will be the processed images and labels are also stored. Iterating over the dataset. It iterates through the dataset paths that are training dataset and testing datasets. Training path and test path. Images comma labels is equals to empty list. It initializes the empty list to store image data and also to store the label data. Print f loading dataset. It displays the message that dataset is currently being loaded or loading. Iterating to the folders. It iterates through the each subfolder inside the dataset directory. Each folder represents a specific disease category, whether the leaf is healthy or white fly or yellowish or any other different category. Next, iterating through image files. For file in TQDM os.list directory folder path, It loops through all images in the folder. Image path. It gives full path of the image. Image is equals to cv2.imread. cv2.imread is nothing but it reads the image using the OpenCV. Image is equals to cv2.cvt color. It converts the image from BZR to RBZ, red, green, blue. Next, it resizes the images. Actual size of the image will be 256 into 256, but it will resize the image to 150 into 150 pixels to get the better consistency. Image.append. It stores the processed image in the image list. Labels.append label. It stores the numerical labels in the list. Converting list to NumPy arrays and normalization. It converts the list of images into NumPy arrays and normalizes the pixels values to improve the model performance. Next, returning to the processed data. It returns the dataset as a list containing the tuples. Loading dataset. It calls load data and assigns output to train images and train labels, test images and test labels. Next, we are shuffling the train data. We use shuffle function from the scikit-learn to shuffle the data randomly. Here we are loading and pre-processing the data. Load data is a function to load the images and the labels. Next, we are initializing the empty list. Printf loading dataset. It shows the message about the dataset whether it is loaded or being loading. For folder in os.list directory dataset, it is looping through folders and it is looping through folders in the dataset. Next, assigning the label to each folder using class name label. It creates a full path to the folder. For a file in tqdm, reading each file inside the folder using cv2.imread. By using cv2.imread, it reads the image. It reads the each image in the folder, and next it converts the image from BZR to RBZ and also resizes the image to 150 into 150 pixels. Images is equals to np.arrays images comma dtype. It converts the list into NumPy arrays. Normalization is nothing but dividing the images by 255. Here we are implementing a CNN model, which is nothing but convolutional neural network using the TensorFlow Keras to classify images related to the Michi disease. Sequential is a function used to define the CNN model. First, convolutional two-dimensional layer. It has 32 filters and 3 by 3 is the kernel size of first convolutional two-dimensional layer. Here activation function is ReLU. Input shape means the input images should be 150 into 150 pixels with 3 color channels RBC. Here we used max pooling to reduce the image size. Actually the image size is 3 by 3. We are reducing to 2 by 2. Next, now second convolutional two-dimensional layer plus max pooling layer, which it is used to help for extracting the deeper image features. TensorFlow.keras, it is used to flatten. Flatten is used to convert two-dimensional matrix to one-dimensional array. Dense 128 comma activation function ReLU, which means it adds fully connected layer. It adds the fully connected layer. Dense 5 comma activation function softmax. Softmax is used for multi-class classification. It is the output layer. ReLU for fully connected layer and softmax, it is the multi-class classification and it is the output layer. In this CNN model, we have used the optimizer, Adam optimizer for the learning purpose. Loss function sparse categorical cross entropy. It is suitable for multi-class classification. Metrics accuracy. It is the accuracy of a model, or it is the accuracy to track the model's performance. Metrics is used to track the model's performance. History is equals to CNN model dot fit train labels testing images. We are training the CNN models with the batch size. Batch size is given 15. That means processing 15 images at a time. It will take 15 images at a time. If the batch size is 13, it takes the 13 images at a time. Epoches is equals to 10. It means it runs through dataset 10 times. If the epoches is given 8 times, the dataset will be run through 8 times. Valley split is equals to 0.2. It uses that means it uses 20% of the data for the validation. Saving the model. We have to save the model. We have to save the model in H5 format. Model JSON is equals to CNN model to JSON. That means converting the model to JSON format and saves it. JSON format stores the model architecture but not weights. It does not store the weight of the model. Print model saves as Michi CNN model dot H5 Michi CNN model dot JSON. That means it displays the confirmation. The file name is image test. This is the Flash based web application. It allows users to upload image of a leaf which is analyzed by pre-trained CNN model to classify it. CNN means convolutional neural networks. To classify it into different disease categories. There are 5 types of categories we have taken. The categories are healthy, leaf curl, leaf spot, whitefly and yellowish. We have imported the required libraries. OS, which handles the file operations such as saving uploaded files, and it also allows interactions like reading the files. And we are importing the NumPy library and we have assigned it as NP. It is used for handling arrays and performing the mathematical operations. We have used TensorFlow as TF. TensorFlow, it is a deep learning framework which is used for building and training the neural networks. Actually, this file image text is being about data modeling and data evolution. The before file train main is about data collection and data preprocessing. TensorFlow.keras. Preprocessing image. That means it provides the utilities to load and process the images. Flask is mainly used for front end, which is used to create the web application. Render template. It is used to load HTML templates. And request. Request library handles HTTP requests, especially for uploading the files. Next, initializing Flask app. App is equals to Flask name. That means this initializes the Flask web application. Name tells that Flask to determine where the app is running. Next, we have to create upload folder. In upload folder, the uploaded images will be stored. os.make directories upload folder exist OK is equals to true. That means we have to create the folder if it does not exist. If it already exists, there is no need to create the folder. App configuration. That means it configures Flask to use this folder. Next, loading the pre-trained models. This section loads previously trained models. These are saved in JSON format. Michi CNN model dot JSON. That means it contains a architecture, model architecture. It involves layers and activation function. Michi CNN model dot H5. That means it contains the trained weights. For example, imagine that you have trained the CNN models to classify the diseases and saved it. Now you can reload the model so it can predict new images. Next, we are defining the disease categories. That means class names. There are 5 categories of the disease. It defines the list of categories for the prediction. When an image is processed, the model will assign it one of the labels. Def predict disease. It is a function to predict disease. Image.load image. It loads an image and resizes it to 150 by 150 pixels. Image.img to array. It converts to array and normalizes it. np.expandDim. That means it expands the dimensions to make it compatible with the model. Dim means dimension. Loaded model.predict. It uses CNN model to predict. np.argmax. Predictions axis equals to 1 and in list 0. That means it finds the index, class index. It will find the class index. Next, it returns class name. Flask route for home page. That means it defines the home route using the symbol /. When the user visits the site, Flask will load index.html. Flask route to handle file uploads and prediction. File not found in request files. That means it checks the file is uploaded or not. File is equals to request.files. That means it will get the file. The file should not be empty. And we have to save the file to the uploads folder. Predict disease file path. It calls to get a prediction. Result.html means it will display the result. Running the Flask application. If name is equals to main colon app.run. That means the Flask app will run only when it is executed directly. If it is not executed directly, then it will not run. Actually, this code is useful for automating mid-leaf disease detection through deep learning and web application also. Here we are discussing about execution part. We have to search for Ankonda Navigator and click on it so that the Ankonda Navigator page was loading. Here we got the home page. Now move to environment file and then to project. The project file is being loaded. Then open the terminal. Here we got Anaconda prompt terminal. Now we have to go to the files and set the path. We have to copy our path and again we have to go to Anaconda prompt or command prompt and change the directory and paste the path. In this we are using Python language so that we are giving Python. First file we are using is train main file. We are giving Python train main.py. As you know, py is the extension of Python. Now click enter. Here the train main file was loading. Here the instructions and operations of train main file was loading. And now we have to go to the next file. Now I am opening image test file so that we are giving Python image test.py. As you know, py is extension of Python. And now click enter. Here the image test file is also getting loading. And then we got URL here so that we have to copy the URL once and go to the Google Chrome and paste the URL. And now click enter. So that we are getting the home page here. And there is the option like choose file. Here now I am choosing a file and selecting detect disease. Here we are getting predicted results like leaf spot. And again I am choosing other file to upload. And now select detected disease. And now we are getting predicted results like whitefly. Like that we can choose some other images, some other files related to chili leaf, and then we will get the predicted results. Thank you.